Hello everyone, we are excited to present our project developed as part of GDSC Solution Challenge 2025. Our team has tackled a deeply impactful problem, enhancing communication accessibility for the deaf and hard of hearing community. Our focus is on real-time sign language translation, a crucial need in the world where millions rely on sign language but often face communication barriers due to a lack of interpreters or awareness. The challenge is to bridge this gap affordably, effectively, and inclusively. To solve this, we built a machine learning based system that translates static and gestures into both text and speech using just a standard camera. Our solution works in real time, allowing making it more accessible and scalable for use in schools, workplaces, and hospitals.
This is the architecture of our solution. It starts with a camera capturing hand gestures in real time. Media pipe detects and tracks hand landmarks, which are then passed to our deep learning model built with TensorFlow. The model translates these gestures into text, which is then converted to speech using text-to-speech engine like PyT, SX3, or GDSC. We use Flask or Fast API for deployment, and the output is shown through a user-friendly interface built with Streamlit or OpenCV.
Our solution uses computer vision to detect hand gestures in real time with a machine learning model trained to recognize full gestures instead of individual characters. These gestures are converted into text and can also be spoken aloud using speech tools. The system is built using Python and runs on a lightweight web server with a simple user interface to display the results. This is our MVP. Uh, on the left, you can see that it runs on a desktop. As well, on the right, you can see that it runs on a mobile device. Here's the demonstration. The gesture I'm showing is yes, and the gesture I'm showing now is I love you.
One.
So for our future development, we are planning to introduce two-way communication for the people who do not have any visual impairments to the ones who have visual impairments. We'll also try implementing speech-to-gesture translation using models like GTTS, Google Text-to-Speech, and we'll also introduce contextual output where we'll use natural language processing to fully build and grammatically correct sentences from gesture sequences. We'll also introduce gesture synthesis. We'll have 3D avatars and dynamic animations to enhance the translation. And and why all it matters is we are empowering communication, breaking barriers, and building a more inclusive world. Now to our repository. So we are Team Socrates. Our problem statement is building an inclusive world for neurodiverse individuals, which falls under the United Nations Sustainable Development Goals, Reduced Inequality, Goal 10. Next. Many neurodiverse individuals face barriers to communication, particularly those who rely on sign language. These barriers affect education, social inclusion, and access to opportunities. This project addresses the need for real-time translation of sign language into readable text to empower those with hearing impairments and foster inclusivity in society. So when we get to methodology, first we have the data collection script. We use OpenCV via webcam to capture gestures, frames, and we have introduced like 1,000 images for each class. We have 7 classes in total. So you can run the script by running it in terminal, python data collection.py. You can click on S to save images and Q to quit. We have data augmentation script. Capturing each and every frame through data collection script would be tedious. So we have data augmentation script, which improves data diversity by introducing techniques like rotation, flipping, brightness, and noise injection. You can run this by calling it on terminal python data aug.py. We have model architecture. We have used a pre-trained model called MobileNet v3, which is a CNN, We have freezed first few layers to retain the knowledge and fine tune it for our custom needs. For training, we have used 32 batch size with 50 epochs and 80% for training and 20% for testing. We can run it by Python model 3.py. And for inference, we are using Python test.py. As soon as you run the script, you can actually run the module, GUI module, which will show the gestures recognized. Next. So for key features, you can use GPU acceleration by installing CUDA and CUDNN. Also, you can verify whether you have GPU access by running this code. So key features of our MVP is lightweight. It's MobileNet v3 based, which is very fast. We have real-time sign recognition, built-in data augmentation pipeline. It's easy to expand. It's deployable on desktop and mobile devices, and it's designed for better inclusivity and accessibility. We have used the MIT license here, and our team focuses on empathy through innovation, inclusion through code. Team Socrates, GDSC Solutions Challenge 2025.